Okay, so here's how we do objective number 10 on potential energy. When we're doing objective number 10, we want to keep in mind our units. Let's just go ahead and work through this. We're going to use the formula for potential energy equals mass times gravitational pull times the height. Now, a person weighs 78 newtons, climbs up a 5-meter ladder. How much potential energy does the person have on top of the ladder? So our formula, potential energy, equals mass times gravity times height. The mass is 78 newtons. Gravitational pull, we're going to assume that we're here on Earth, so it's 9.8 meters per second squared, more or less. The height is going to be 5 meters. Now, that's a lot of crazy units, but we know that it's going to be in joules. So we do the math. We're going to go 78 times 9.8 times 5, and we'll end up with 382.2 joules. That will be the potential energy in that example. Example number 2 says Bill lifted a load of bricks that weighed 15 newtons onto a platform 9 meters above the ground. Bob lifted a load of bricks that weighed 17 newtons on a platform 8 meters above the ground. Whose bricks have more potential energy? So we have two different scenarios. We have Bill and we have Bob. In Bill's case, again, we're looking for potential energy. Mass, gravity, times height. The mass for Bill is 15 newtons. I'm just going to use the numbers here. Gravity, still on Earth, 9.8. Height is 9 meters. So for Bill's example, we have 15 times 9.8 times 9 equals 132.3 joules. In Bob's example, Bob has, again, using the formula, potential energy equals mass times gravity times height, where your mass is 17, gravity is still 9.8, height is now 8. We'll multiply 17 times 9.8 times 8 equals 1332.8. Let me double check my numbers here for the first example. 15 times 9.8 times 9. Sorry, my decimal's over here. Should be 1,323 joules. Not that one. So out of these two, while they were very close, Bill had slightly more potential energy in that example. Number 3 says, refer to the roller coaster diagram in objective 8. At which point does the roller coaster have the most potential energy and why? Well, that diagram looks a little something kind of like this. So when we look for the most potential energy, that's the point at which the roller coaster is the highest above the ground. So that would be in position A. So position A, why does it have the most potential energy? Because it's the highest above the ground. Now number 4, talking about the same illustration, when does the roller coaster have the least potential energy? That would be in position F, because it is at the ground, or you could say it is the lowest position. And that's how you do objective number 10.